Hi, everyone. Welcome. Welcome. Nice to see you all. So I'd like to welcome you to the second presentation in our wonderful series. And Dorothy, if you would like to say a few words, you're welcome to. But we're repeating something we did last fall because it was, just much more popular than we thought, where we're just kind of look at birds. All right, a thorough look at birds. Last class or last presentation, I'm sorry, which was recorded. If you didn't get a chance to see it, you're welcome to check it out again. Was on feathers and an introduction to birds. Today we're talking about how the world got its birds, how dinosaurs slowly became birds. Next week, we look at the life history of birds. I mean, just because as we talk about birds, rather than repeat, all of, this material and nesting, etc., let's just talk about their life history. And let's pick the bald eagle just to kind of make that the sample bird, talk about the life of a bald eagle with the idea that a lot of those concepts will apply later. And then we start getting into all the groups of birds: waterfowl, aquatic birds, raptors, and we go through the list. And then towards the end, we'll get into some environmental issues and some other aspects of birds. If this is interesting to you, I just want to, recommend that in addition to these presentations, you have people who are just as interested in birds as you, and we get out on occasion. Last week, we went for a bird walk at 6.5 Station Road, saw some great birds. Thank you very much for those of you who are here who joined us on that walk. This Sunday, we'll be at the Bashkill doing a nature walk at 10 in the morning there. One of the neat things, we were actually doing an environmental cleanup, a bunch of people this Sunday. And at the end, I decided to take some pictures of birds. And I got really good pictures of a cormorant swallowing a pickerel that was about this big. It was like bigger than its mouth. It was just amazing going down. So in any case, there's people who like getting out, liking seeing nature, like observing birds. And so if you're interested, the Orange County Audubon Society manages 5 sanctuaries. If you wanted to look at their events, you can see presentations, field trips, and the like. The Bashkill Area Association helps to protect the wonderful wetland of the Bashkill, which is about a 20-25 minute drive from here. Great birding and kayaking, etc. You can actually now rent kayaks there. You can rent them specifically from the Mamakating Environmental Education Center. There's the other Audubon societies in Sullivan County. There's the Mearns Bird Club. There's just all of these great organizations that help promote wildlife. So if this is of interest to you and you'd like to get out among people who feel similarly or join some of these groups, they would love to have you, and they're all great. All right, but on today, I apologize. I'm a teacher and old habits are hard to break. I'd like to start with a quiz, if you don't mind. All right, so I didn't warn you last week, but them's the breaks in education. So question number 1 in the quiz is that a bird? All right.
It's an eagle.
You guys are doing good. Off to a good start. Good start at home. All right. Second question, is that a bird? All right. Doing great. All right. Is that a bird?
Yes.
All right. Is that a bird? Oh, you guys are like, you guys apparently didn't even need to study. So apparently you're really good at telling birds from non-birds, but then that begs the question, how'd you get so smart? How'd you do it? How do you know? What about them told you that they were birds? Anyone? Feathers. They fly. Okay, excellent. Okay. They have beaks. They're bipedal. Ooh, very good. Very good. That's a good one. I don't get that often. Anybody else? At some point, I have to turn off this flood of answers. Any final contestants? Oh, they lay eggs? They brood over their eggs? Okay. Song. Okay. I'm going to stop you right there. So you guys, you did a great list. Oh, there's one in the chat. Let's read the one in the chat. Hollow bone, very good. Hollow bones and holes in the bones in addition. I'll get to those in a second. So that was a good list that you gave. Now, And Dorothy
I'm
kind
gonna
of
eat some
hint.
cucumbers.
Okay, yes, you can have some cucumbers, but if you don't mind, I'm just going to mute you.
Oh my God.
That's okay.
No,
All
he
right.
heard me.
Oh, okay, hold on. Where's all the people? Okay, sorry. I got a mute. Okay. So those were a good list. That being said, no criticism. Um, it wasn't a perfect list because while everything you said was good to distinguish between birds alive today from the things that aren't birds, like deer or bugs or whatever, a lot of dinosaurs had the same features that you mentioned, or the first birds didn't have what you mentioned. And so nothing that was said here was universal. So nothing could be used to say birds have this. This is a bird because it has these features, because the features which we raised would either include non-birds like dinosaurs, or they would not include all birds, especially not the first ones. Now, I'd like to talk about then how bird anatomy slowly came to be over like 150 million years. It is a wonderful, wonderful story. But if you don't mind, if I'm going to talk about bird anatomy, I'd like to kind of add to the list if you don't mind. All right. So, what makes a bird a bird? Your list was very good. If you don't mind, I'm going to throw in a couple more things so that we can have an interesting talk going forward. So they have feathers. Not only do they have feathers, they have different kinds. Right? You see here are different kinds of feathers, but then there's flight feathers. Also, notice something I'm going to mention about the flight feathers is that this feather has a vein in the middle, but it's fat over here and skinny over there. That's what's called asymmetrical. And when birds do that, you know that they fly. If their wings are asymmetrical, or they have asymmetrical feathers. So when we talk about dinosaurs, we'll talk about that. But there's fluffy feathers as well called downy feathers. All right. If you were to say, what makes birds fly up here? What shoulder girdle do they have? They have a really weird system where they have a strap for a shoulder blade. Oh, so your shoulder blade's kind of diamond shaped. This is a shoulder blade for a bird. All right. So its scapula long and thin. That's weird. Its two collarbones are fused to make what's called a wishbone or a furcula. And then there's a third bone, the coracoid. So that's their shoulder joint. They have that. They have this weird system. I'm going to zip through these things just so that you've heard the terms once, and then over the course of the hour, then they'll come up again. They have a weird thing that where those three bones touch, there's a hole. All right, so right here, there's a hole that allows a tendon to go through. So the muscle that pulls the wings up is actually under the wings. That's a neat trick on their center of gravity, and so we'll talk about that. They have wings. All right, so if we were to look at the wings, here are all the bones of the wings. We get to talk about that. They have these ribs, which are reinforced. So if you were to look here, they've got ribs going down. They've got ribs going up. So they got ribs from their breastbone going up, and they've got these little reinforcements here to give them an extra strong thorax. Their sternum, their breastbone, it comes way out. It has what's called a keel. So somewhere, I swear, I could have held this up. Look at that. Like, imagine if my breastbone came out to here and my chest muscles were here. I mean, they'd be huge. And then if I did this with my arms, you would see things happening. There is fusion all over the place in the avian skeleton. All right, so if you were to look here at this thing from an emu, what is this? This is a whole bunch of bones smushed together. It's 3 hip bones. It's a bunch of vertebrae all fused together. It's called a synsacrum, and that's just the beginning. Birds have fused bones all over their skeleton. They have holes in the bones for their lungs. Yes, I repeat, for their lungs. If you look at bird bones, there's holes everywhere. And if you ask why, birds have the best breathing system, but they also have the most complicated. It takes birds 2 breaths to get air through their system. So on breath number 1, air comes in their throat, and then it doesn't go to the lungs yet. It goes into a bunch of air sacs. Then as they Then on their second breath, then it goes into their lungs and then out into more air sacs and then out. So it takes 2 breaths for this to come through. But a lot of these air sacs go into holes of the bone. Okay, so there's all this bird stuff. They've got, weird legs. They've got 3 toes pointing forward. And the question then comes to us. How did that start? All right, where did birds come from? And the answer is, if you were alive in the early Jurassic period, that would be, 200 million years ago is when the Jurassic started. Shortly after that, there would be things in the trees with feathers that were dinosaurs, but not birds. And there would be things in the trees with feathers that were birds, but not dinosaurs. And it would be really, really hard to tell them apart. So your list and the list that I just gave, really good today. You can tell a bird from a non-bird, and you did a great job at that. But if we could go back in time, you wouldn't get it right all the time. Some of the things you called birds would be dinosaurs, and some of the things that you called dinosaurs would be birds. So this then gets us to, there are rules in science. You just can't just use words without permission. So like if you're going to use the word dinosaur, like you can't say, oh, I found a bunch of birds, I think it's a dinosaur. No, there are rules. There are traits that you have to be a dinosaur. There are traits that you have to be a meat-eating dinosaur. So if you're going to look at a family tree for each of these nodes, for each of these groups, see all those words, those are anatomical terms. Those are the things that mark the group. And as we start getting up closer to the early dinosaurs and the ancestors of dinosaurs, once again, there are rules. And one of the things about dinosaurs is they had the coolest legs. So I'd like to talk about the dinosaur legs. And this gets us to birds. So ask a quick question. Can you do that? Can anyone do that with your leg? Anyone? All right. So you all got the question wrong. Of course you can do that with your leg. You're doing it right now. All right. And if you're saying, no, I'm not. Well, it's because I think you're looking at this wrong. All right. Because a lot of you might say that's the thigh. Oh, no, no, no. The thigh's here under the feathers. That's the lower leg. That's the knee. That's the ankle. All right. So if you look at a flamingo, right, there's its thigh. All right. There's its knee. There's the lower leg. There's the ankle. There's the foot. So birds have long feet. That's a foot. The ankle is up here. All right. And so if you were to look at a dinosaur, let's pick Tyrannosaurus Rex. It has the same leg. All right. So birds will have evolved from meat-eating dinosaurs. And so the weird legs that birds have, the dinosaurs that came before them had them. So there's a thigh. All right. There's the knee. Here's the lower leg. But see how high the ankle is? A dinosaur like T-Rex was walking on its feet. All right. And so we see the same bones here as in, oh, I'm sorry, I see there's a chat question. Hi, you might want to send, like, okay, I'll do that again. Okay. Okay, I'll send the link out again. So there are the similarities in the bones. So if you wanted to, I'm just zipping through these videos, but I have a much longer set online if you'd like. If you could say, there's the femur of a bird leg, there's the femur of the T-Rex leg. Here's the tibia and the fibula, there's the tibia and the fibula, and here's all the weird ankle and foot bones. And they are really unique, but to go into it more would probably be more details than you'd like. But they match, all right? So a bird leg is the leg of a dinosaur. Dinosaur hips started off being really weird, all right? So this is an alligator. All right, it does have a little bit of an expansion on 2 of its hip bones, the ischium that goes back and the pubis that goes front. By the ancestors of dinosaurs, it gets a little bit bigger. All right, so here you can see that one's a little longer. That one's a little longer. And then by the time you get to the first dinosaurs and their immediate ancestor, it's longer still. So in other words, this is confusing when I look at T-Rex, all right? Because when I look at, humans and other hips, like here in this region, there are long thigh bones, all right? You can't confuse a thigh for something else. But here, Here on the dinosaur, there's a thigh. That's not a thigh. That's the pubic bone. That's not a thigh. That's the ischium. If you don't know the ischium, if you sit on your hands, you feel a bump where your hamstrings come from. That's the ischium. In dinosaurs, it was as long as the thigh. In dinosaurs, the pubic bone was longer than the thigh. So you look at all those bones, all right, and the thigh has competition. There's a whole bunch of big bones in here, but that meant that the leg muscles were really powerful and they could walk upright. All right, so one of the comments earlier was that what made birds unique was that they're walking upright. Well, dinosaurs got this leg that allowed them to walk upright, and then birds would expand on that. Now, later, all right, tell you what, I'll get to later. So at the start of dinosaurs, the pubic bone is long but goes forward. That's going to change later, but we'll get to later. Okay. All right, so dinosaurs get these weird legs that let them be bipedal, and birds will then retain this as well. So by the time we get to the first birds, all right, this is Archaeopteryx. If you were to list traits that the meat-eating dinosaurs had that birds would have, it's all of these red ones. So birds did not appear suddenly, and the reaction was, wow, look at all of these traits we've never seen before. The meat-eating dinosaurs start with these red ones. Later meat-eating dinosaurs like Allosaurus get even more, including holes. These holes let bird lung, or the air sacs attached to bird lungs, extend into bones, giving them the best respiration among the vertebrates. But dinosaurs started that. And as we go up the family tree, there would be a little more, a little more, a little more. So this adaptation, which allows birds to be, such good breathers as they fly, was a dinosaur trait that they simply then improved on. And then there are the feathers. Okay, so these are feathers, and they're asymmetrical. If you notice, this part of the feather is fat, and that part is skinny. Dinosaurs did not start off with those. Okay, but as we remember from last week, dinosaurs, feathers serve multiple functions. So like black and white. All right, white feathers are reflecting heat, black feathers are absorbing heat, black feathers strengthen the tips. They provide camouflage. They help you know who your mate is, because if you're a duck on a pond and there's all of these species, who do you have sex with? All right, well, you have to learn, green heads go with this group, big white spots on a black head go with that group, etc. So that's a use of feathers. All right, if there's a whole bunch of species around, you know who your partners are. Your mate might look at you and determine how healthy you are. So cardinals, they put red pigments from their feathers in their diet so that females can say, ooh, this male is healthier than that one. Okay, well, in any case, birds have feathers and they use feathers for different things. Here's an early meat-eating dinosaur. And if you look close, it's fluffy, right? It doesn't have scales. It's fluffy. Now, it wasn't flying, but once again, feathers do more things than just flight, including keeping the animal warm. All right. And so I don't know what you want to call them. Some people like to call them proto-feathers. Some people don't like the term feathers. They're really strict and they say collagenous integumentary structures. I don't care what you call them. Okay. But dinosaurs had something. So dinosaurs had this on their skin. This is, or some of them, this is a neat find because this is dinosaur skin stuff trapped in amber. Is it a feather? Well, we talked about feathers last time. A lot of feathers have like these interlocking barbs. That's not, like a feather, right? But it's certainly on the way. That's not a scale either. All right, so that is not the scale we associate with reptiles. So dinosaurs were starting to cover themselves with fluffy stuff. All right. What it was doing, don't know. It would probably help to keep them warm. If it was brownish or greenish, it might help them camouflage. It might help with courtship. Feathers do a lot of things. These could have done a lot of things before there was flight. Okay, so by the point of, like maybe Allosaurus in the family tree, some dinosaurs had feathers, and this one, Sinosauropteryx, was the first one where that was definite. All right. And I've been teaching prehistoric life probably for like 25 years. I think it was like my 5th year that this fossil was so popular, it was actually touring the world. And when we took our class to the Museum of Natural History in New York City to see it, we got to see this thing, which kind of changed it. Before this, it wasn't accepted that dinosaurs had feathers. Now we know that lots of dinosaurs had feathers. So that was a kind of exciting thing. This one had feathers on its tail. All right. Here's an early tyrannosaur. It had feathers. Here's a later, bigger tyrannosaur. It had feathers. So we don't know whether Tyrannosaurus rex had feathers or not, but it certainly could have because its ancestors did. All right, so no reason to assume that T-Rex wasn't fluffy. So we'll get back to feathers in a little bit. As we go up the meat-eating dinosaur family tree, all right, and I would be happy to make this a 2-hour presentation where I go into that in greater detail. I opened all these things. Oh, there we go. Yeah. Because the family tree of dinosaurs includes all of these different branches. All right. So you see, so if this is the first meeting dinosaurs here, all right, then they get a little more advanced, a little more advanced. Each of these colors matches a new group. And as you can see in purple, a lot of them is like, ooh, dinosaurs from this point on had a lot of features that they didn't have before. A lot of these are the features that help to make birds, flying birds, the way we have them. And the point is, some of them came from this point, some of them came from this point, some of them came from this point, etc. I am very specific on that. If you're, okay, I'll close that if the noise kept, let me close that. Are you looking for a bird lecture? Okay. If we were to get to what makes a bird, the long list would come in different colors so that some come in pink halfway through the meat-eating dinosaurs. Some things come a little bit later. Some things come a little bit later. So each of these colors come at different points along about 150 million years. So birds were built over enormous periods of time. Right, so there's this gradual change in which these dinosaur-like birds, or I'm sorry, these bird-like dinosaurs become dinosaur-like birds. So if we're in the middle of the bird family, the dinosaur family tree, we start noticing other things. In addition to feathers, they start brooding on their nests. We know of a bunch of meat-eating reptiles and a couple of non-meat-eating reptiles that sat like this over their eggs, and the eggs have the structure of bird eggs. Dinosaurs start to take their collarbones and fuse them to make a wishbone, right? So birds have wishbones, almost all of them, and dinosaurs started then doing that as well. And they start to get smaller, this one branch of the meat-eating family tree, and they start to get a new kind of feather. They start to get the feathers, which we sometimes called flight feathers. So flight feathers obviously are important in flight, but these first things that had them, they couldn't fly. So here's the song that you were listening to earlier. Okay, here's a dinosaur. It has flight feathers on its arm. It has flight feathers on its tail. Could it fly? No, it couldn't. So it has flight feathers, but couldn't fly. Not only couldn't it fly because it was too heavy, also they weren't symmetrical feathers, or they weren't asymmetrical feathers, so that indicates that they weren't flying. So that raises the question, what were they doing with these flight feathers? And we don't know. Maybe it was for courtship. Maybe it could help them scoop up prey. Maybe they were jumping after their prey, and this would help them glide a little bit. So flight feathers had a function before flight. All right, so dinosaurs developed flight feathers before they were able to fly. So that's interesting. And their arms started getting longer and longer. So this is a dinosaur hand. This is a bird wing, the first bird. And if we color in the bones, They are close to identical. The bird wing is just a little bit longer and thinner, but all the same birds are there. So most of the modifications, like, so the way a bird holds its wings like this, by the time you get to like Velociraptor of Jurassic Park fame, Velociraptor was holding its arms like this. All right, this strap-shaped shoulder, this scapula, that's what a dinosaur scapula looked like. All right, so the arm bones, the pectoral girdle bones of a dinosaur arm and hand were looking more and more like an avian wing. And if they're getting longer arms and they're getting a better and they're getting flight feathers, then it's only a matter of time before some of them could, quote, fly, question mark. So were there dinosaurs that could fly? All right, well, here we start getting into the physics of how light you are, how long your arms are, and what we think you could have done. And obviously, we can't watch any of this. So it's hard to say, there's a new chat. Why did dinosaurs develop holes in their bones? Okay. So why did dinosaurs get the holes in the bones? Well, apparently this very efficient breathing system that birds use, dinosaurs were using as well. Now, birds, it really helps them fly, but with dinosaurs, I'm sure a lot of them were using it to be really good runners, et cetera. So it probably just helped them be really efficient with their breathing. So here's a dinosaur. It actually has flight feathers on its arms and legs. Some people wanted to change it from Microraptor. Micro means small, and actually if you take the tail off, you could have held this one in your hand, right? That's how small it was. They want to change it to Tetrateryx, which means 4 wings. Meaning that if you've got flight feathers on your arms and legs, then if you started doing this with both limbs, would they both be functioning as wings? The flight feathers were asymmetrical, fat on one side, skinny on the other. So this thing was flying. All right, when you get an asymmetrical feather, that's to help you fly better and resist the forces from the wind. So here we have something which was small enough to fly, had flight feathers on 4 limbs and a tail, asymmetrical feather. So this would have been capable of flight, or at least, you know, this is a philosophical question. I don't want to argue with anyone. We could, take it up after class. Where does gliding well end and flying badly begin? Right? Philosophically. So if you're gliding really well, and every now and then you throw in one of these, all right, that's really good at gliding. It's not great flying, but are you on the cusp there? So where does one end and the other begin? I'm not quite sure. So dinosaurs, a couple of them can certainly glide. I mean, because heck, there are frogs that glide and snakes that can glide. So feathered dinosaurs could certainly glide. Could some of them fly? At least a little. Microraptor probably could a little. And then there's the weird group. I don't want to talk about them because I don't understand them very well. Right before the bird branches off, here's a group, they had feathers. But then they decided, instead of going the bird route, they said, ooh, bats are cool too. Not that there were bats yet. They decided to get a bat-like wing membrane. So birds fly with their feathered arms, bats fly out with a wing membrane. There was a small group of dinosaurs that tried both simultaneously. They didn't last that long, all right, but they were there. So dinosaurs were trying to get better at flying, and they were trying different things. All right, so these are cousins of birds that were being a little creative with, what they were doing. Right. And if we were to go back to, we start going up the list, there's more and more feathered dinosaurs everywhere you look. All right, so Caudipteryx, once again, we'll show, they have feathers on the tail. There you can see a nice set of feathers on the tail. There's feathers around this one. In fact, some of them, we know what color the feathers were. So one dinosaur had black feathers with white stripes and a reddish brown crop. All right, so here you can see how well those feathers are preserved. Velociraptor from Jurassic Park fame, do we know that it had feathers? Well, we don't have feathers preserved with the fossils, but most rocks wouldn't preserve feathers. But we do see dimples. There's a dimple, there's a dimple, there's a dimple, there's a dimple. We see dimples on the forearms of birds where the flight feathers attach, where their primaries attach, all right? So Velociraptor, we don't have feathers with it, but we have what seem to be where feathers attached. So Velociraptor could have had feathers, and later Jurassic Park's kind of added those in. There's some weird ones because last week we showed you that great blue herons can have just like some ribbon-like feathers that are just look like long scales almost. Well, some of these birds had long scales. And look how long those arms are. All right, so once again, you need wings to be long arms to have a wing. Bambi raptor, could it fly? Maybe badly. This one was thought to be a bird before they realized, oh, it's a dinosaur with the same slicing toes that Velociraptor have, but it could probably fly. Okay, here's Microraptor again, flying. Before we kind of come to the big finish on the halfway point here, something happens with the hips where they decide, oh, we used to have this long ischium, this long pubis, but the pubis would go forward. You know what would be cool? How about we take the pubic bone and swing it back round, swing it back, and then just give more room for intestines. So this is like a regular old dinosaur hip, but the pubic bone, instead of going this way, has now gone this way. So Velociraptor had that. A lot of the final groups of dinosaurs had that. And I like to bring that up because this is the hip of an emu. And it doesn't look like, our hips. It's got, all these fused bones. It's got a hole here. Like your hip socket has bone in the back. Dinosaurs had a hollow, an open hip socket. Birds have an open hip socket. But here we have, once again, the pubis and the ischium. Ours are kind of short. They're not these long things which are as long as the thigh, but in dinosaurs they were, and in birds they can be. But here we have the new change where the pubic bone goes forward. T-Rex, or what goes backwards. T-Rex had it still going forward, but by the Velociraptor group it was going backwards. And so we have that. And just somewhere. Oh, I swear it should be here somewhere. Okay, we'll go to the next one. There's a bit of a trick. Okay, I guess I do it. I'm sorry, I've got a couple different PowerPoints. Does anyone know what this dinosaur is? Okay. This is Archaeopteryx, the first bird. Okay. So dinosaurs became more and more like birds, so that there were some of them that were actually thought to be birds, but then later, hey, welcome. That's okay. They were thought to be birds, but then they said, oh, no, this is a dinosaur. This one was first thought to be a reptile, but then the feathers were observed, etc. And then they realized, oh, wait, this is an ancient bird. So not only do the dinosaurs look like birds for the longest time, here we have a bird, the first bird, Archaeopteryx, which looks like a dinosaur. Now, there's a couple other people who argue, hey, no, I found this thing in Texas that's a little bit older. I think that should be the first bird. This one we have a lot of skeletons of, so if it's okay, I'd like to talk about this. But, there might be some other contenders as well. Okay. So once again, I have videos if you're super interested. The videos go into more details than I'd like to hear, like especially on the skull. Like I'll talk about the various points here. But this is a bird. But it reminds us a lot of dinosaurs. So like the teeth, right? Not only does it have teeth, but they remind us of dinosaurs. A lot of the things I'm pointing out here are features that birds do not have today, but the dinosaurs did. The bones aren't fused yet the way that they would be in modern birds. So once again, if you really want the specific details, here you can go through like bird bones, all the bones fused. So you just see a skull. You don't see like separate bones. But they were once separate and then they all just fused together. Okay. So the first bird did have bird-like features. Now, this is frustrating to me because I've asked experts and I've tried to much as the research as I've done, because I would like to get the question right that I asked you earlier. I would like to say, what makes a bird a bird? So this is a bird and not a dinosaur. Why? What does it have that makes it cross the line? And the answers really won't impress you. The Velociraptor group already had long, thin arms, all right, that were making the wings. This one has just a little bit longer, all right, little longer, little thinner. So that's significant, but it's just an extension of what dinosaurs already have. One of the biggest ones is it has a perching foot. This thing could have sat on a branch with 3 toes pointing forward and 1 toe pointing back. No dinosaur had that, but dinosaurs were close. They did have 3 toes, big toes pointing forward, and they did have this one little one that's on the side. Wasn't pointing back, facing forward, but it was halfway there. So that birds just took something that dinosaurs were already working on, just made it a little bit better. The first birds had asymmetrical flight feathers, but so did Microraptor. And I'm actually getting close to the end of the list. So if you ask what makes a bird, and you're expecting something dramatic, there's really not a whole lot dramatic. And on the this video, if you don't mind me going back to this, if you were to ask which of these makes a bird right? So I'll go through all of this, here are the closest relatives of birds, and I talk about those. But if you're asking, all right, here we are with birds. Let me just get to the text. Where were you? Come on. It's okay. So it's the green. All right, this light green here. Those are the features that the first birds had better than the last dinosaurs. But by the time you get to the end, all right, so if we were to jump through the end, sorry, not to be a spoiler. All of these things make birds really good at being birds and flying, etc. But can you see how few the green are? So the very first birds had a couple of modifications that the dinosaurs didn't, but not many. A lot of the things, all right, like here in red and purple, they came before the birds within the dinosaurs. And a lot of other things like the aqua I haven't gotten to yet. Birds were built slowly. And that line that they crossed to be first considered birds by us and no longer non-avian dinosaurs, yeah, they got a couple of things, all right, but not overly, not a huge list compared to some of the other features. All right, so, oops. So by the middle of the Jurassic period, we have birds. But they're not good at being birds yet. Okay, and they certainly aren't good at flying. Okay, so I'm looking for. I'm sorry, I'm missing one video. Oh, there. Okay, we'll start here. Okay, so if Archaeopteryx looked like this, it had teeth. Modern birds don't. It had a long reptilian tail. Modern birds don't. It had clawed, grasping fingers. Yes, it could fly with these wings, but it also could catch prey with these wings. So in a lot of ways, it reminds us of a dinosaur and not a modern bird. Well, once the middle of the Jurassic comes, these things say, all right, well, let's get better at this bird stuff. So let's start modifying this. The first thing that they do is change the tail. All right, that's the first thing. Once we get birds, they say out of everything we need to fix, this long reptilian tail is number one. So they develop what's called a syn sacrum, where oh, I'm sorry, that's the here, my fault. They develop a pygostyle, which is where the last vertebrae of the tail fuse together. So after Archaeopteryx and a couple of others, they have a short tail, and we can actually see intermediates in that as well. So from here, Archaeopteryx, right? We've got birds with long reptilian tails, right? But then from this bottom tail, this is a modern bird. Then they started doing this, taking the vertebrae at the tip of the tail, smushing them together to make one solid bone that's called a pygostyle that the tail feathers attach to. All right, so that was number one. Okay, the next thing that they decided to do was to change their chest. Because if you're going to fly and you're this light bird that's, developing these incredible forces, etc., you got to change this stuff. The first birds were not good at flying. If you've ever seen like a Canada goose take off from a pond, it can't do this and be airborne. It has to like flap a while on the surface of the water, slowly gaining altitude. The first birds would have done that. They would have had to run for a while flapping, or maybe climb up on a tree, jump, and flap on the way down. They couldn't have taken off from nothing, and it would have been their thorax which would have then changed. And there's a whole bunch of then features which change here. So let me go back to the things I went through rather hurriedly earlier. Around now, the bird shoulder girdle is changing, right? So not only are they fusing these bones together better, they have this weird hole that only birds have. Here we have 3 bones touch in the shoulder girdle, the scapula, the coracoid, and the wishbone, the furcula. But birds put a hole there so that a tendon from a muscle under the wing can go up and over the wing. And the thing about the chest is birds want to change their center of gravity. If you're going to fly efficiently, you want your center of gravity here. So you don't want a big head full of teeth, because that makes you heavy on this side. You don't want a long reptilian tail. That would make you heavy on this side. All right. You want your center of gravity here. And if you've got big muscles on your back that can pull your wings up when you fly, well, once again, now those wing muscles have to push up against these big muscles. If the big muscles which help the wing go up are actually under the center of gravity, that takes less energy. So that was a modification. After the first birds, we're getting better. Oh, wait, there's more. The first wings would have looked a lot like a hand. Like that looks like a hand to me, a grasping hand. And if you were to take Archaeopteryx, so this is the first bird. I know what's going on there. Look, it has a red humerus. I got a humerus. It's got a radius and ulna. I have those. Look, it's got some wrist bones. It's got 3 clawed grasping fingers. So this wing looks an awful lot like an arm. It even looks like my arm with 3 fingers. But by this time, we're starting to fuse some of the bones together. We're losing some of the external digits. And so we're just modifying those bones which were already there to become here. The wing muscles, if you were to ask what exciting wing muscles do birds have, you'll be disappointed. They have yours, right? So they have a biceps brachii, all right? They have a triceps brachii. They have a brachialis, right? So they have a lot of the same wing muscles that you do, right? And these are just now modified for flight. But you've got bones in your forearm that extend your digits, flex your digits. Birds have the same. So they didn't need new muscles there. They have a deltoid, all right? They have both the pectoralis muscle. So we've got pectoralis chest muscles. They've got pectoralis chest muscles. Okay. The one thing that they did is the chest muscles have to get bigger because of that keel. So they took their breastbone and they made it come out to here. So now their chest muscles have to be this big, which gives them the power of flight. If you had chest muscles which were this big, there'd be some exciting things happening when you did this too. All right, but here's a modification here. Here they have ribs. Notice the ribs have little processes going back that anchor them together. Plus, these ribs are going down. Here are ribs from the sternum going up. Point is, birds partway through their lineage changed their chest. And they said, let's get serious about flying. All right, because the early birds, they could fly weakly. But now these birds were good at it. Or they were capable of powered flight, taking off from a standstill because of some of the modifications here, the keeled sternum and the extra muscles, etc. And now for the first time in this group that had modified their thorax, They're good flyers. So the first birds were not as good as them. They are now. And from this, two lineages appear. Now, this is weird because in an egocentric way, I expect that once birds get good at flying, they're going to get busy at becoming hawks and ducks and cardinals and the birds that I know. That's not how it worked. In fact, most of the birds at the end of the age of dinosaurs were going a completely different way, forming a group that has died out. So birds at the end of the age of dinosaurs were in two groups. Our bird ancestors are the minor group. The major group, the one that was most diverse, the ones which could go from vulture size to sparrow size, the first ones to lose their teeth, they are completely extinct. They are not the relatives of modern birds. So birds were just branching out, trying lots of new things, but a big rock falls out of the sky. Not only does in the last of the dinosaurs, most of the dinosaurs, but the most abundant early birds as well. But some survived the mass extinction. All right. Before the mass extinction, they weren't all that impressive. There were a couple that looked like gulls. There were a couple of toothed diving birds. Okay. But they were not the diverse groups that they would come today. So this group that would lead to our birds, they still had teeth, they still had claws, etc. Okay. But when the dinosaurs died out, that then is where the lineages which we get to know where they first appeared. So how did our birds come to rise? Well, the most primitive branch, so the oldest branch of birds still alive today, seem to be the ones which have what's called an old mouth. This first one you won't recognize. It's a small South American bird that can fly called a tinamou. I just want to stress that this one can fly because all the rest of them can't. So that's a primitive bird, one of the most primitive birds alive today. And once again, it would be, you'd be looking at the roof of the mouth to tell why. Just it has an old reptilian mouth, not a new modern bird mouth. But the other ones in this group that you do know would include emus and ostriches and rheas. They are flightless and they live on the southern continents. All right. So ostriches, rheas, emus, cassowaries, and the tinamous, they are the most primitive birds alive today. And here's just one other thing I like about this rhea. Somewhere. It still has, all right, I should find it first. It still has a claw on its hand. I swear. We'll hit it somewhere. Somewhere I have it bigger, but here's a rhea. There's a claw. There's a claw. There's a claw. Now, a few birds still have claws. This emu did, but I've been told that great blue herons under their feathers have like little tiny ones. So claws will go away gradually. Teeth do too. All right. Birds have teeth for a while. In fact, there are mutant chicken which make chicken teeth. So, you know, the genes for teeth are still within some birds. So those ostrich rhea groups, they branch off. And then comes another group called gallo-anseri, which is a fancy way of saying the ducks and the chickens. So gallo, that's a group for the chickens and the turkeys. Anser, that's a group for the ducks, the geese, and the swans. So here's the big question. We know that that's the next big group of birds. So the old mouth birds, they're branching off, then followed by the fowl. All right, so that would be the waterfowl and the chickens, the ducks, etc. When do they branch? And the question is, do they split right before the dinosaurs died? So did T-Rex see an ancestor of ducks which had really long legs? Or did all of this happen after the dinosaurs died? We think that right before the dinosaurs died, the modern bird family tree had started to branch. So you would have the ancestors of chickens, the ancestors of ducks, and the ancestors of ostriches and the like, right before the split. But this split was so massive, wiping out 60% of life. And then life accelerated so much in its aftermath to evolve, it's really kind of hard to piece together exactly when some of the splits in the family tree occurred. So either way, we then have the ducks and the chickens. All right, they are a lineage with splits. There are some ducks which have really long legs, known from the fossil record. All right, here. Now, I'm just going to, if you don't know, here's the age of mammals starting after the Cretaceous extinction. And the first 10 million years is called the Paleocene. And we have about 15 million years called the Eocene, the Oligocene, the Miocene. And then here we get started getting into ice ages and recent history in the last like 5 million years. Okay. Most of the bird most of the bird groups we know, they are coming early in this age of mammals. All right, so if we were to refer to bird orders, all right, so the ducks go way back, right? But how about like, I don't know, like woodpeckers, right? When do they come from? Well, they're coming in much later. So no dinosaur ever saw a woodpecker, right? And before there were woodpeckers, there were primitive birds that slowly got woodpecker features. So here's something called a wryneck alive today. It has some woodpecker features. Then there's something called piculets. These are like cousins of woodpeckers. They have a few more woodpecker features. And then we get into the woodpeckers, which gradually have more. But this develops over time after the dinosaurs had become extinct. In the same way, if we look at the raptors, the birds of prey, all right. No dinosaur ever saw a hawk or an eagle. These are only age of mammal ones. And so these evolve slowly. And there's differences. So for example, when we use the word vulture, the vultures of the Americas were different from the vultures of Europe, Africa, and Asia. So these are American vultures. They're related to condors. The old world vultures, they are a completely different group. I said the first ducks had long legs. The first raptors kind of had long legs too. And here's something called a secretary bird from Africa. It's a cousin of hawks and eagles, but you can see how long its legs are as well. So it took the birds we see today a while to look the way they do. And a couple of them actually took an interesting side route. All right, some of the early ones still had claws. So here's a southern screamer. You can still make it out. It has claws on its digits. Some of them got to be really big, like 6 feet tall, 9 feet tall. Moa's got to be 16 feet tall. Diatrama had the skull the size of a horse. Because if you took away all of Earth's big predators, eventually mammals would take that place. Mammals would develop wolves and bears and saber-toothed cats. But that took a while. So when the dinosaurs died, there were no big predators left on Earth. So a lot of the birds said, we could do that. And so if you go throughout the world for the beginning of the age of mammals, these little mammals, like horses were the size of cats and a little bit bigger at that time. They were running away from the birds. The birds were the scary things that were, preying on all of the early mammals. Yeah. So no one knows the answer to that. I don't know the answer to that. But if I were to say, here's one big clue, everything that survived was small. So size was a factor in. Right, when there were no big predators left on Earth, right. So they're in a world where there are no big meat eaters. And they said, hey, if we get bigger, we have things we can eat. One of the other thing, mammals did better than most. A lot of mammals are nocturnal. A lot of mammals burrow. Because what would have happened when the rock hit the Yucatan Peninsula where Guatemala and Mexico meet, it would have thrown up so much Earth stuff. That would have been bad. But worse is then when it came back down. Because meteorites, they're like this ball of flame that burn up. But imagine like a gazillion meteorites all coming down at the same time. That really would have heated the atmosphere. They think not only like oven temperature, like pizza oven temperature. All right. And so just that temperature would have been devastating. but small things that maybe had burrows or caves or things like that, maybe that offered some protection. But I'm just making these things up now. Like, that makes sense. But I can't say this is why birds made it and they didn't. Because remember, most birds didn't. The most successful groups of birds from the Mesozoic, they died. It was this other lineage that that made it. One final uh, thing is that songbirds are the last big order of birds to evolve. So if you look at the birds, the family tree of birds, the chickens and the ducks, that's an early lineage. All right, raptors come pretty early after that, but songbirds come later. So no dinosaur ever saw a sparrow. In fact, none of the early mammals saw a sparrow or a cardinal or heard the bird songs the way that we do today. And one of the modifications that comes last, because I think, Dorothy, you might have mentioned the bird song. There are singing birds, the songbirds, they've modified their trachea to form something called a syrinx. So that's why if you've ever heard eagles make sound, it's nice, but it's not a song. It's kind of like a little scary and screeching. Hawks have like a screech. Great blue herons, it almost sounds like a cackle. Okay, so the songbirds, they not all, the first birds could not sing. All right, so ducks can't sing in that sense, herons can't, etc. So that would have been this order Passeriformes, which would have appeared for the first time partway through the age of mammals. So birds have this long history, and we're still trying to figure it out because until recently, all you could really do is you could say, all right, well, let me compare their anatomy and kind of look at, similarities that I see. But now what you can do is you can compare their genes. You can just say, oh, let's compare their DNA sequences and then make all of these family trees based on that. Now, because there are so many different kinds of birds, like constructing these vary. Every year they get better, but at first they were only using a couple of genes, then a few more, then a few more, then a few more. So we keep improving on this. But there are surprises along the way. So for example, falcons were considered raptors. They aren't anymore. Well, I mean, they are birds of prey, but they're actually closely related to songbirds and parrots, and they're not related to hawks and eagles at all. As we can touch on next week, some eagles are related to these hawks, some eagles are related to those hawks. So the word eagle really isn't a group. The word hawk really isn't a group. And there's a whole bunch of examples here. So as we compare more and more of these, these genetic sequences, we're sometimes having to rearrange our groupings of the birds. Mm-hmm. So the question, I know people at home can't hear voices in here very well. Question was, why, if raptors aren't related, do they relate act similarly? Well, one thing I would say, so like take the
Bird
vultures.
class.
So take vultures, for example. New World vultures, when they're hot, they defecate on their legs to cool down. Old World vultures don't do that. The hawks and eagles don't do that. So there are some differences like, ooh, you guys, you're doing this, that's different from this. There are certain things that things do, like bald eagles are fishing eagles, ospreys are fishing eagles, but ospreys are not related to bald eagles at all. Ospreys are really good at fishing. Bald eagles are like bald eagles are more efficient at taking fish away from ospreys than they are catching them in the first place. All right. So there are similarities, but then there are also some differences as well. Over the course of these talks, I would like to, there's so many stories. There's so many great birds. There's so many birds that you could see if you go on a bird walk at any time of year in Orange County, but especially in the next 2 months, because we're going to be having Canada's birds migrate through here. This is such a great time of the year to get out. I want to, tell all of their stories. So after 2 weeks of just kind of introducing, well, this is what makes a bird, I'd like to start telling the stories of the group, starting with the bald eagle next week. After that, going through the ducks, etc. Because there's exciting ducks. One of my favorites are blue-winged teals. They're for the past week, they have been 20 minutes away from here. They are just so neat to see. And then we'll get into other aquatic birds. Then we'll get into woodpeckers and owls. Then we'll get into the songbirds. So hopefully get to tell all of their stories over the course of these weeks. Once again, thank you for coming. If you ever can't make one, I will record these so that you can see them. But also, we went out last week for a bird hike. We're going out at the Bashikill, 10 o'clock this Sunday. We'll do more of that. And there's other, groups. So I lead a bunch of walks, but Mern's Bird Club has a lot of great walks, etc. If you'd like to get out, not only could you do this yourself, I'm sure, but there's a lot of organizations of kindred spirits who would love your company. If anyone has any questions, please feel free to stay. But otherwise, thank you so very much for coming, and we'll hopefully see you soon. There's some things in the chat. Yes, please. No, northern pintails. Have you seen pintails yet? I haven't.
Not yet. Not yet.
Oh, not yet. Oh, I love
I'm
Yeah,
waiting
pintails
for
are great
Peter
birds.
Pan.
Yeah, I haven't seen any yet.
When do you give walks? Would you put a
So,
schedule and email it to us?
So I'll be honest, I am a board member of the Bashikill Area Association, so I help them out. And I'm vice president of Orange County Audubon. So if you were to go to the Audubon page and just go to their field trips, right? Here you would then see, oh, here's an upwarm. Here's Sunday the 14th at the Bashikill here. Here's the next one I'm doing at Long Swamp near Warwick, etc. The Bashikill they just sent out an email, I think, today with this same walk. So, Bashikill members are more than welcome. Audubon members more than welcome. Everybody is more than welcome. So like it doesn't belong to one group per se. But if you went to any of their websites, you could find some of these.
Okay, thank you.
Thank you. Thank you for coming. Oh, thank you. Does the effectiveness of hunting by dinosaurs was less efficient than birds? That's kind of tough because, with bones, there's only so much you can tell. Like if you showed me someone's bones, by someone, I mean an animal, a dinosaur, I'm not sure I could get a good guess of how fast they were, like how good their eyes were at spotting prey. So that would be tough. But then dinosaurs, I mean, T-Rex, and a bunch of others, they were like, 40 feet long and longer, but then you had small ones which could fit in your hand, and the birds were so varied. I think both of those groups were so big. I'm not quite sure. Obviously, the birds could catch things from the air, like they could swim over, fly over a pond and grab a fish, or go up in a tree, and come down on something that most of the meat-eating dinosaurs wouldn't have. So they probably would have been hunting in new ways or different ways. Good question.
Why wasn't teeth a more important thing in like deciding what is a bird? Our modern birds don't have teeth, but yet primitive birds like Archaeopteryx have teeth.
Right. So that was not originally a bird feature. Birds had teeth for tens of millions of years, and then different groups of birds lost them at different times. And so the big thing is, I want my center of gravity here, and if I've got big, heavy chewing teeth here, it's better to have a gizzard. So like a turkey can crush walnuts with its gizzard. That's how strong it is. We mammals would try to use it with our molars, but if I'm a bird, that just makes me top heavy. So the loss of teeth did mark some of the later groups of birds, but it wasn't a defining feature of birds till much later. You're welcome. You're welcome.